Imagine where the stars quit sparkling, and grandiose frameworks decide to call it quits. What secrets could sneak past this as-of-late found limit? Are we on the edge of unraveling the greatest endless mystery? Or is this simply the beginning of an altogether unique chapter in our understanding? Well, it seems so. Webb cases have found the completion of space itself. Yes, you heard it right. The last edges may not be so unfathomable after all. But hold on a second. How could space have an end? Wasn't it supposed to continue forever? Okay, let's figure out what's truly happening. When I heard this news for the first time, I was completely guided to uncover one of the many mysteries of the universe. The James Webb Space Telescope has been doing exactly that, flipping the way we interpret the universe on its head. In just 12 hours of observation, this marvel showed us things that left us wide-eyed and scratching our heads. Now, imagine together how colossal the universe truly is. Let your imagination wander and stretch as far as your mind can take you, reaching the very edge of space. But first, let's figure out just how far the James Webb Space Telescope can see. The reality is astonishing. So, hop aboard our imaginary spaceship and let's not waste any time. We first head to the edge of our planetary system, passing planets like Mars, Jupiter, Saturn, Uranus, and Neptune. We've now covered 100 astronomical units. And here we are at the boundary. Beyond this point, we enter interstellar space, where Voyager 1 and 2 have ventured. Next, we approach the Oort cloud, a mass of space rocks 200,000 astronomical units from Earth. It's sparse, and we can easily navigate through the asteroids, entering complete darkness. Zooming past stars and planets, we arrive at the edge of our galaxy. Within minutes, the Milky Way's spiral arms vanish, replaced by brilliant specks of distant galaxies dotting our path. We realize our universe isn't infinite. It has a boundary about 10 billion light-years away. But there may be other universes beyond. The first supervoid, a billion light-years wide, could be evidence of a collision with another universe. But how could we reach these other universes? Black holes might hold the key. Their mysterious warping of spacetime has led some scientists to propose the existence of white holes, the opposites of black holes. These could serve as portals to other universes. Remember the Big Bang? In 2006, an odd burst of energy might have been a baby white hole, destroyed almost instantly. Now let's examine the Andromeda Galaxy, hurtling toward us at 68 kilometers per second. Don't panic. It won't crash into us tomorrow. But when it does, things will get interesting. We could witness a magnificent collision, or perhaps our solar system will be flung into deep space like a tennis ball released from a rope. Fast forward millions of years. The galaxies merge, and their central black holes begin an intricate dance, eventually combining into a supermassive black hole. It will emit energy, lighting up a vast region of the universe. Then there's the South Pole Wall, 500 million light-years away, containing a quadrillion stars, and the Hercules Corona Borealis Great Wall, a flat superstructure 10 billion light-years wide. Don't forget the giant quasar group, 4 billion light-years across and 6.1 million times heavier than our Sun. Closer to home, the visible universe contains over 500 billion galaxies, each with billions of stars. But there's also a mysterious void, the Eridanus supervoid, a region a billion light-years wide. Some believe it's caused by a collision of universes, with two cosmic bubbles touching and tearing material away. Picture the universe as a giant bubble, with infinite other bubbles. Wormholes or portals inside black holes could act as shortcuts between these universes. Imagine folding a piece of paper to connect 2 points without crossing the entire sheet. That's the concept. Falling into a black hole might even be survivable, depending on its size. Instead of being spaghettified, you might end up in another realm with different physical laws. For now, though, it remains a wild hypothesis. On a clear night, gazing at the stars, they may seem evenly spread. But in reality, they form part of an immense cosmic web connecting galaxies across the universe. Astronomers using the James Webb Space Telescope recently discovered what could be the oldest strand of this vast network. In 2 papers published in the astrophysical journal Letters, researchers revealed a massive filament of 10 tightly packed galaxies stretching an astonishing 3 million light-years. Shani Danieli, an astronomer from the University of Arizona, expressed his amazement, saying, "I was stunned by how long and close this filament is. I expected to find something, but I didn't expect such a long, clear, thin structure. It's like stumbling upon an ancient hidden treasure." This ancient filament of gas and stars dates back to 830 million years after the Big Bang, during the universe's infancy. What anchors this immense strand? A supermassive black hole. But it's not just any black hole. It's an incredibly bright celestial object, acting as the anchor for this cosmic arrangement. The researchers are part of the TRI project, which relies on spectroscopic surveys to study uneven crowns during the reionization era. Their mission is to understand how the earliest black holes influenced galaxy formation. One of the 5 early universe quasars they studied led them to this filament. Fan Wang, an astrophysicist from the University of Arizona, was thrilled, saying, "This is one of the earliest filamentary structures ever seen, associated with a distant quasar. It's like discovering a treasure map revealing the universe's early secrets." The team believes black holes played a critical role in shaping this massive web, acting like magnets that pull matter together with gravity. But they also eject matter with so-called cosmic winds. Over time, gravity holds these strands of stars and dust together, even as cosmic winds try to scatter them across the universe. So, what's the fate of this ancient filament? The experts predict it will eventually form a cluster of galaxies, much like the Coma Cluster, located 330 million light-years from us. It's like watching the universe build its own masterpiece over millennia. When the Webb telescope focused on a patch of sky, it revealed far more light and galaxies than anyone ever expected. The patch of sky observed by the James Webb Space Telescope contained an extraordinary amount of detail, more than scientists could have dreamed of. It wasn't just the sheer number of galaxies, it was the depth of history they uncovered. Each galaxy was a time capsule, showing the universe as it was billions of years ago. One of the most astonishing revelations was the discovery of galaxies that appeared far older and more massive than they should have been, given their place in the cosmic timeline. These galaxies, formed just a few 100 million years after the Big Bang, challenged the conventional understanding of galaxy formation. How did they grow so large so fast? The telescope's infrared capabilities allowed it to peer through the thick clouds of dust and gas that often obscure these ancient structures. Scientists marveled at the clarity of the images and the data they retrieved, revealing the intricate details of star formation, galactic collisions, and even the presence of early black holes. As the team analyzed the data, they began piecing together the story of the early universe. The filaments of the cosmic web were not just random structures. They were highways of matter, guiding galaxies into clusters and feeding them with gas to fuel star formation. These highways stretched for millions of light-years, connecting everything in the cosmos in an intricate, interwoven tapestry. Among these filaments, they identified regions of intense activity. Bright knots of light where galaxies were merging and black holes were growing at an unprecedented rate. These were the cosmic cities of the early universe, bustling hubs where gravity pulled matter together to form the seeds of the galaxies we see today. One particular region, nicknamed the Cradle of Stars, captured the team's attention. It was a nursery of young hot stars surrounded by glowing clouds of gas, shining like a beacon in the dark. The cradle provided a glimpse into the processes that created the first generations of stars and, eventually, the heavier elements that make up planets and life itself. But the discoveries didn't stop there. The telescope also detected faint signals of light coming from even deeper in time. These signals, known as the cosmic dawn, marked the moment when the first stars ignited, ending the universe's dark ages. The faint glimmers of these ancient stars, though barely detectable, were enough to rewrite textbooks and inspire new questions. Could there be other universes beyond the one we observe? Could the structures we see, filaments, clusters, and voids, be the result of interactions with other dimensions or parallel realities? The idea, once relegated to the realm of science fiction, now seemed plausible. The James Webb Space Telescope had not only given humanity a window into the past, but also a mirror to reflect on its place in the vast expanse of existence. As the data poured in, one thing became clear. The universe was far more dynamic, interconnected, and mysterious than anyone had ever imagined. And this was just the beginning. Every new discovery raised even more profound questions, pushing the boundaries of human knowledge and understanding. What secrets would the universe reveal next? The answers lay not just in the distant stars but in the collaboration and curiosity of those who dared to ask the impossible. Expected any worlds as well as huge splendid ones. Now analysts are scratching their heads and concocting different potential outcomes to make sense of this infinite secret. They're similar to crossroads, each prompting new inquiries and understandings. Decision 1. Maybe stars and systems formed differently and more efficiently in the early universe. Imagine a faint room without many stars and systems, making it easier for them to shape rapidly. It's amazing, yet not an outright change from what we know. Decision 2. What if the brightness isn't from stars but from exceptionally massive dark holes? That's right. Rather than a universe loaded with stars, we might be seeing galaxies illuminated by these strange dark holes. However, if true, it challenges what we assumed we knew about the quantity of these monsters existing in the early universe. Decision 3. The most extreme possibility is that our understanding of the universe's recipe book, called cosmology, is incomplete. It's a radical idea, but it could upend our comprehension of everything. Decision 4. And then there's the extraordinary case option. There may be some unknown piece of the universe that we haven't even considered. Why does this matter? Well, everything revolves around finding our place in the universe and understanding the narrative of how we arrived. If we're missing something vital in this story, solving the mystery is like trying to complete a puzzle without all the pieces. The more we dive into this enigma, the more questions arise. Ongoing discoveries from the James Webb Space Telescope have given us a reality check about the size of the universe. We might have been off course. Specialists recently dropped a bombshell in a paper, claiming that the telescope captured glimpses of phenomena just a brief time after the Big Bang, if the Big Bang even happened. It challenges the very foundation of the standard cosmological model. The universe probably isn't as old as we thought, and Einstein's idea of it being infinitely old seems to have failed. Our instincts have been deceiving us, and we're starting to realize we don't truly understand what's out there. The James Webb Telescope explores space, attempting to see far. It can reach around 46.5 billion light-years away, within what we call the Hubble sphere. The most distant galaxy ever found by the telescope, GNZ 11, existed only a few hundred million years after the Big Bang and is still within this Hubble sphere. Our universe is like a balloon that's constantly expanding. Beyond the Hubble sphere, the universe is expanding faster than the speed of light. Yet, the Hubble sphere won't grow forever. There's a cosmic horizon limit, an invisible shell around us, 93 billion light-years wide, which represents the farthest we can observe. But how large is the entire universe beyond this vast shell? We don't know. Competing theories suggest it could be infinite, while others estimate it might be 1 times larger than what we can see. The distribution of matter in the universe and the even spread of temperature in the cosmic microwave background radiation suggest that the universe may indeed be infinite. Yes, you heard that right, infinite. When we look into the vastness of space, we aren't just observing distant galaxies. We're looking back in time. The galaxies near the Hubble sphere are not representations of the present. They're like cosmic fossils, remnants of a past era billions of years ago. It's like having a time machine that looks far back instead of moving forward. According to our cosmological model, around 13.8 billion years ago, the observable universe was compressed into a small point called a singularity. That's the standard story if the universe is finite. But if it's infinite, as it seems, the Big Bang wasn't a local event. It happened everywhere, even beyond what we can see. The inevitable question remains. What or who created everything from nothing? Einstein was initially opposed to the idea of a Big Bang. He favored the concept of a steady-state universe that had existed forever. However, circumstances changed his mind, and he eventually accepted the Big Bang theory. Still, some people, including scientists, describe the cosmic story not as a beginning but as a universal birth certificate. Just when we thought we had the universe's story organized, the James Webb Space Telescope came and shook our understanding. It recently discovered Sirius 93316, a galaxy so distant that, if confirmed, it could rewrite the history of our universe. The telescope has found galaxies that shouldn't exist. Colossal galaxies appearing just a few 100 million years after the Big Bang. These discoveries are causing upheaval in cosmology. The universe might be older than we thought, or it might not have had a beginning at all. Imagine if our universe is like a favorite storybook that never had a first page. It has always been there, unfolding through different chapters. As we peer deeper into space, the idea of an eternal universe begins to make more sense. If the universe appears infinite in size, why shouldn't it also be infinite in age? Maybe the Big Bang was just a dramatic event, not the initial scene. There are around 2 trillion galaxies out there, yet cosmologists wonder how much more lies beyond what we can see. Virginia Trimble, an astronomer from the University of California, says it best. The universe has always been slightly bigger than anything we can see. It's like the universe is playing hide and seek, and we're desperately trying to figure out where it's hiding. John Mather, a Nobel Prize-winning cosmologist from NASA, explains. We've already seen as far as you can possibly imagine. At the very edge, we get a brief glimpse of the glow from the Big Bang, but this isn't the end of the line. The universe keeps going, and we may never fully know. As they search for answers, cosmologists take inspiration from the ancient Greek mathematician Eratosthenes, trying to determine the universe's shape. Is it a giant saddle, a massive sphere, or a flat sheet? The saddle-shaped idea has few supporters, but the spherical universe feels familiar. Einstein called this a finite yet unbounded universe. However, in the late 1980s, observations of cosmic microwave background radiation suggested that space is flat, like an infinite sheet of paper. This flatness implies that one could travel endlessly in any direction, encountering galaxies forever. While this aligns with current theories, it raises questions about the universe's limits. Virginia Trimble compares the difficulty of determining whether the universe is infinite to figuring out if a pizza is endless or has an edge. This leads to explorations of the universe's boundary and what might lie beyond. Some theories suggest the universe may be a bubble in an expanding multiverse, with different physical laws on the other side. Others propose the need for a model to test the universe's infinity, akin to predicting particles like the Higgs boson before its discovery. The cosmic story continues to captivate and invite exploration.